Okay, so here we are, 7.2C in college algebra, continuing on with matrix solutions. There's my golden retriever laying in the floor of the boat, bored to death with my lectures. So, anyway, we are dealing with non-unique solutions. Now, when we've done system of equations before, you either get one unique solution, like we learned in 7.1 and 7.2. You're going to get an x equal a number, a y, and a z, and you're going to write it as maybe 2, 3, 4. If my x is 2, my y is 3, and my z is 4. It's written that way. I have one solution here, that if you were to draw this graph, and this particular graph would be a three-dimensional graph. It has an x-axis, a y-axis, and then it's got the z-axis that kind of sticks out this way. So you go over 2, up 3, and then toward you like 4, and it ends up being out here in space somewhere. It's kind of hard to draw three-dimensional. But sometimes you get something other than one solution. Sometimes you get an infinite number of solutions, and sometimes you get no solutions. Okay, so how in the world do you know? Well, let's say that you're doing these matrices, and you're running into a bunch of trouble, and when you get done, you end up with a matrix that looks like this. And let's just say that it's a 3 by 3 matrix here. And let's say that you have your 1 and a 2 and a 3 and a negative 5, and you have a 0 and a 1 and a 4 and a negative 6, and you have a 0 and a 0 and a 0 and a 5. Okay, this is where you run into trouble. If your left-hand side are all zeros, and your augment, which is that number right there, is a non-zero, then there is no solution to this problem. Okay? There's no solution at all. All right, so let's go and look at what it would look like if we had an infinite number of solutions. So we have, again, our matrix augmented, and let's say that we have a 0, a 0, a 0 here, but instead of a number, we have a 0 there. So the entire row is zeros. Then we have an infinite number of solutions there. And in green on page 527 it says, a system with fewer equations than variables, which would be this case right here. So let's say that we have a system that looks like this. Okay, we have a system here, but the system has 2 equations and 3 variables. So a system with fewer equations and variables, this has got 2 compared to the 3 variables, has either infinite number of solutions or no solutions. Okay, so that's what was going on right here, where we had 0, 0, 0, and 0. That meant we had an infinite number of solutions. Whereas when we had, this was not a 0, but maybe it was a negative 6, then we have no solutions. Okay? So if one of the rows has all zeros here and a 0 here, then there are an infinite number of solutions. If it has all zeros here and a number here, then it has no solution. Okay? So that will just happen. It's not something you have to figure out. You'll be just doing your work, da 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 da, just like normal, listening to your music, and doing your math and you end up with, wait a minute, what the heck's going on? All these zeros are here. Well, you're running into either an infinite number of solutions or no solutions. Okay, so just be prepared for that. Okay, so that bumps us up to example number 4, a dependent system. And we will start that dependent system example in the next video.